Hi, everyone. Thank you so much for joining. I'm really excited to be here, and I'm really excited for what we have in store today. We're going to be building and deploying a data processing application in Azure, and we're going to learn how with Visual Studio Code we can save time and keep focus on writing code by creating, deploying, configuring all these Azure resources directly in our coding environment. Um, the talk is focused on a Python application, but the learnings are more broadly. So if you don't necessarily use Azure day to day, Python day to day, sorry, it'll still be applicable to you. At the end of the talk, we'll have about a 10-minute Q&A, and I'm joined by my co-moderator, Nina, who is a developer advocate focusing on Python and open source. She's really well known in the Python community, does tons of talks. They're all over YouTube, definitely worth checking out. And a little bit about me. For those of you who don't know me, I'm a PM on the Microsoft Python tooling team. Our team is responsible for the Python experience in Azure and in Visual Studio Code and Visual Studio. And so I get to work with a bunch of different teams. I get to talk to tons of different customers about what they're doing with Python and Azure. And we get to build a bunch of cool stuff too, one of which is what I built today. I'm also a dad. I have a 1.5-year-old son at home. And so there's not as a lot of uninterrupted time these days. And so I definitely understand that productivity is absolutely crucial. And so these little tips and tricks here and there should help you as well. And like I mentioned, our team invests heavily in improving the overall Python experience. In today's talk, we're going to talk about how Python is a first-class language, supports multiple OSs. There's free tiers on almost every service. There's a fantastic Python SDK that really ties it all together. And in today's talk, we're going to be covering these 5 Azure services. From a data processing perspective, we'll be using Azure Functions for serverless, Cosmos DB for NoSQL, Azure Storage for file storage, cognitive services for machine learning, and we're going to host and deploy your application all through Azure App Service. Now, if you don't know what these services are, that's okay, because we're actually going to go over them one by one as we introduce them into our application. And this is what we're going to be building today. You're going to see this diagram a lot, so don't worry about memorizing it. We're going to be building a GitHub issue visualization tool. And what that's going to mean is we're going to download tons of different data from all over public GitHub repos. We're going to go look at each issue created and extract the key phrases using machine learning. And then finally, it's gonna be all visualized through a web application. And so the reason I thought this was interesting was from a data side, since we're using serverless technology, we can scale the data processing and processing application up and down based on whether I want to download 1, 2, or 5 files, or maybe hundreds or thousands of files concurrently. And it's able to handle a large amount of data. Each one of these files are hourly files with over 100,000 different events. And so it's really nice to be able to do that and wrap it all in Azure Functions. From an intelligence and machine learning perspective, I'm able to add natural language processing into the application using cognitive services, and that's going to power extracting those key phrases, and so we know what the key terms are in each issue. And then finally, we're going to visualize it and make it real, and for that we're using Azure App Service. I like Azure App Service because it's really fast to get to production and it just kind of works, and we'll get more into that a little bit later. And this is going to be emphasized throughout the talk, but this is all about how VS Code helps supercharge that Azure development. And so with all the key integrations they've built in with all these extensions, it really helps you kind of focus on writing code and less so much configuring cloud services. I know at least for me, as I'm going into the portal or even trying to use things through the CLI, things just take time to load. They're a few clicks away because it does so many different things. And so a lot of the benefits are the fact that a lot of these activities we've identified that developers do often are just 1 or 2 clicks away. But also, if you're like me, context switching does have a measurable impact on at least my development cycles, especially with a little toddler running around. I don't get a lot of uninterrupted time, and so it's a little difficult. So anytime I can improve my efficiencies, I'm going to jump at it. And these are some of the requirements today if you want to follow along. That ak.ms link on top will drop you off at the repo that has clickable links to each one of these, as well as the slides, the repo, and things like that to follow along. That link will persist through the rest of the slides going forward, so don't worry about writing it down really quickly. So let's jump into the data processing section. First, I want to introduce our first service. This is Azure Functions. Azure Functions is a serverless event-driven platform. Basically, all that means is it really just lets you run code in the cloud, and it does it on demand. And so as I go to trigger my function, servers will spin up, it'll run my code, and then they are transient, so they'll eventually spin back down once they're no longer being used. And that means they scale really well because I can spin up multiple servers or just a single server depending on how many things I need to do concurrently. It's also extremely affordable. I have trouble myself spending any money using Azure Functions because you get 1 million requests a month. which is also why it makes it really nice for things like cloud automation or connecting services together. People use it for ML endpoints or even just standing up APIs. And so there's a ton of different broad cases for using it, but today we'll use it in two different ways. So the first way we're going to use it is we're actually going to use Azure Functions to call APIs for us and download these files. And so we have a function, number one, is going to download the files and store them in Azure Blob Storage. That function is going to be triggered through a URL call to, we call it an HTTP trigger. And so as I call the URL and pass in parameters, giving an hour, day, month, and year, it'll download the files for me and drop them in Azure Storage. As that file gets dropped into Azure Storage, our second function, which is triggered by data entering Azure Storage, will trigger, and that data will be passed along into that function where it will unzip the data. It'll do a lot of the heavy processing, filtering the events to just new issue creations, shaping the data, and eventually dumping it into Cosmos database. So what I want to do now is jump into our first demo. So let me go ahead and pull it up on the screen here. And what we have is an empty folder here, and I want to show you the create process for Azure Functions. And so if you have the Azure extension installed, you'll be able to click to this Azure tab. And if I go here and click this create folder project, what's going to happen is I'm going to get prompted with a few different queues asking me for language and name and things like that. Once that prompts up, I'll go and answer that. So I'll select my folder, I'll select my language, and then eventually it'll pull up my Python interpreter so I can choose which of my Python environments I want to use. In this case, I'll use 377. It is taking a little while because I have 5 VS Codes open at the same time, plus live streaming, so bear with me. I can choose the trigger. So like I mentioned, we're using an HTTP trigger, so we can call it, give it a name, and select the fact that it needs a key to be called, so it can be private. To save us some time, I'm going to flip over to my next screen, which actually has it already created, just to save us some time. And what you can see here is it is a simple hello world function. And so apart from maybe this first line, which is taking this request parameter variable, it all just looks like normal code you might run locally on your machine. And so here we're extracting the name from the parameter name and then printing it out here, hello world. So it's pretty interesting. You can quickly get to your first template and start coding from there. But let me show you a more interesting example. And this is the first step in that 2-step process for a data processing application. Now, what you can see, the first thing it's doing is it's defining these parameters for year, month, day, and hour, which I can append to the URL, and you can see in this example below for when I'm running locally. Then it's calling the request API and passing in that string so I can download the file. And then in just a few lines of code here, I'm able to set the connection string, establish a client with blob storage, and upload the file using the Python SDK. And so let me go ahead and hit F5. And what that's going to do is it's going to initialize the debugger. And once that initializes, I'm going to be able to run this locally. And that way I'm able to make as many changes as I want to get it working to the way that I want it to work before I actually go and deploy it to Azure. I'm able to set breakpoints so I can see what's going on with variables at that point in the code. So maybe it's in the middle of a try or a for loop, or maybe I just want to stop the code at that spot so I can see what's going on with those variables. So it's starting up now. Like I mentioned, I have a lot of different applications open right now, so my computer's running a little slow, but bear with me. And I have 2 links here. The first link is my local host URL. And so if I go ahead and click this right now, what's going to happen is it's going to trigger the URL. My browser's open, it's trying to load. And you can see now it's starting to initialize. It's going to start spitting out some of the logging information, and it's now stopped at my very first breakpoint. And I can start looking at all the different variables that have been established so far in my code. So you can see all the different inputs, what the string is that I'm actually calling. And if I hit play, it'll jump to the next breakpoint, or I can step over by hitting F10 or pushing this, and it'll move one by one through my code. And so if I go hit play and then hit play again, what's going to happen, it's going to finalize uploading the file. And so now that the file is uploaded, and what's really cool as well is if I right-click my function, which is already deployed, and click Start Streaming Logs, I can actually pull up my streaming logs and see what's going on in real time locally. Or if I run the Azure URL, let me pull that up really quick as well. It'll also start showing the Azure Function URL as well, and all the stuff going on there. So a bunch of really cool stuff there to help you really just debug quickly and figure out what's going on. You can also view in storage itself to see everything going on in there. So if I go to the storage extension and click through my blob container and get to that raw, I can see all the different files that I've uploaded. If there are things like text files or something, I could actually double click them and open them up directly in my coding environment, which I think is just super, super cool. And awesome. So the last thing I want to show you is how to deploy. So deploying is as easy as creating. You can go ahead and select the subscription. If you multiple subscriptions, you can redeploy by selecting one of the functions that already exist. If I want to create a new function, I can go ahead here and put a unique name that'll be used for people to call my function. Hopefully we can get to something unique quickly. I can select my runtime, choose my resource, and now it's actually deploying into Azure. And in about 30 seconds or so, I'd actually be able to call that exact function. So let's jump back into the PowerPoint. Let's start talking a little bit more about the machine learning aspect of this. But before we do that, just some of the key takeaways. The big one, obviously, is, again, those integrations with VS Code help speed up your development time. Being able to create pre-made templates in a few clicks is really nice. You don't have to scour the internet looking for some example that you can copy. Saves you time there. Debugging locally, being able to set breakpoints in your code, in your function, understand what's going on, being able to see live streaming logs directly in Azure, both for your local development and the ones going already triggered in Azure, are super, super helpful. I can't imagine not being able to test locally, to be honest. Nothing ever works the first time. And so if I had to deploy to Azure and then go and try and figure out what's going on and redeploy, it's going to waste a lot of time. And then finally, that right-click deploy is really nice, especially as you're iterating, prototyping early on in your development. You're able to really get to something quickly, and then you can worry about source code later. And so the extension is really nice to help make you super productive with Azure Functions. So like I mentioned, the next thing we're going to talk about is machine learning. And a little bit about what this is going to do. So again, we're using Azure Functions, this time more as an orchestrator. So the Azure function will use a Cosmos database trigger, meaning that as records enter our Cosmos database, those records will be batched and sent into our Azure function. As that happens, what we're going to do is we're going to call the Cognitive API service to extract key phrases from every issue title. So we'll rely on their machine learning models to extract key information for us. And once we do that, we can append that data to the rest of the JSON blob, pass it into the second table, and from there we'll be able to eventually read it from our web app. And like I mentioned, I'm going to introduce what some of these new services are. The first one, cognitive services. And what that does is it obfuscates a lot of the machine learning work. So there's obviously, anytime you have a machine learning model, it's a ton of time to build it. You have to manage and maintain it, stand up the API endpoints yourself. And so cognitive service obfuscates all that. And so simply it just exposes one API endpoint that you can pass information to and get everything back. So in this case, I could pass a string like the weather is nice in Seattle. And I may get back the two entities it's identified, weather and Seattle, as the key phrases in that sentence. And so the key phrase extraction and the text analytics model is only one of many, many different use cases they manage and maintain. I grabbed just a couple that I thought were maybe interesting to throw on this slide, but there's a ton there, so it's definitely worth taking a look. The other thing that we are introducing is Cosmos Database. It is a NoSQL offering for Azure. It's globally distributed. You don't really have to worry about data schema because it's NoSQL, meaning it's really nice where you can quickly iterate, just dropping JSON in there. It's really great for key value lookups, so things like transactional databases or something around personalization, it works really well for. So let's jump into our next demo. This one is going to be the triggered Azure function that's going to call the cognitive API services. So let me go ahead and pull that up really quick, and let's get into it. So the first thing I want to do is quickly show you the Cosmos database extension. And so if I jump into here, the first thing you can notice is I can actually create database accounts directly from the extension. And so I've already done that here, but if I follow this path, it would ask me about 3 to 4 prompts to create the database. Once I do that, I can go ahead and create accounts, create databases under it, and eventually collections. Where I can even click in and see individual records in the database. And so I can start looking at what do I have in the database? What do these things look like? If I have an empty database, I may want to right click here, create a document, and actually create an empty document so I can start filling out data so my code at least have something to start reading through. The last thing that's really interesting is if I right click the database account, I can copy the connection string, which is really helpful so you don't have to fiddle around in the portal to spend a few minutes grabbing that connection string to bring it back into your code. If you're going to need it in your code, especially as you're iterating early on, it's really helpful to have it a few clicks away. The other thing that's interesting is the environment variables. So Again, right here, we're using local environment variables to read the cognitive API endpoint and keys. And all of that lives in this local.settings.json. And so, for example, we have here the database connection string that I copied earlier. Assuming I didn't have that in there, I can simply go ahead and paste it before, and now my application will read directly from it. When I'm ready to deploy this thing to Azure, that file does not come with me. All the hard-coded secrets are not deployed into Azure itself through your code or into GitHub repos or things like that. What you'll then do is go into back into your function, right-click it, click into it, go to the app settings section, right-click, and you can upload that specific file. Or you can click into it and you can see all the different strings in here that it's preserving for us, and you can see the lists match each other. Let me explain a little bit about what the function is doing. So it takes an input, which we call func.document list or just documents, and it has an output Cosmos database output. And so simply what it's doing is as Cosmos database records get triggered, the function will activate. It sets a few variables for us. It sets up the API endpoints. So in 2 lines of code, I'm able to establish the text analytics client. It does a little bit of formatting, and then eventually down here, it actually calls the API with those batches, and that's simply all the code really the cognitive service API is really doing for us. After that, it's basically just dumping code directly into Azure. And we're able to determine the input and output triggers by this function.json. And so here you can see I've established the Cosmos database trigger as the type and the direction in. So that basically means this is going to be what activates our function. I set the database raw for primary, and here's my connection string. In a similar use case, since I'm spitting it back out to Cosmos DB, the 2 lines look very similar. So let's jump back into our PowerPoint and talk a little bit more about the web app side of things. But first, let's take some of those demo takeaways away. So the first one is those trigger and output bindings. They're really easy to configure. They make great orchestrators between Azure services. I think there's over 18 different ones, from Cosmos Database, Event Hubs, all different sorts of ones. So really nicely to tie services together. The second thing is the Azure Database extension. So Cosmos Database extension we used. It's really helpful to be able to create things, spin them back up really quickly, start dumping records in right away so you could start writing code, copy connection strings. Again, these are all things that save you a few minutes here and there versus going into the portal. And actually what's really exciting is this month they're going to be rebranding the Cosmos Database extension to Azure Database extension and including Postgres, which is super, super cool. And then MySQL is something they're going to work on. And so I don't know when they're going to release that, but hopefully sometime soon. The last thing is cognitive services. So you saw in just about 3 lines of code, I was able to add machine learning into my application without really having to understand all the machine learning, data sciencey stuff to really get that to code. Let's talk about the web application side of things. This is today's architecture for the web app side. So we're going to have an Azure App Service web app. It's a Flask web app that's hosted in Azure App Service. It's going to read from our Cosmos database and using the Python SDK to read from it in just a few lines of code. And this is kind of what the raw data looks like. And you can see the things that I want to call out is you can see the issue title for this random issue is build fails with current NPV. And you can see the NER we've extracted is build and current NPV for key phrases that we think are interesting. And so there's a ton of different opportunities here in terms of what we can do with this data now that we have it. So we can aggregate issues by key phrase, so we can start understanding where we're having issues for which key phrases. We can grab the list of some of the most recent issues that are hitting our GitHub repo, create nice convenient links to those specific issues in GitHub or into the JSON blob to see all the details. We can double click into specific key phrases to see all the issues related to that. So there's lots of cool things we can do. And actually, we built a lot of this into the web app already. And so I'm looking forward to showing that off. Now, before we do that, I wanted to introduce Azure App Service. I've spoken about it quite a bit, but basically what it is it really hosts and manages your web app for you. So you don't have to really deal with all the other stuff. You can focus on writing your code for your application and let us worry about things like web servers, load balancing, scaling. You can also set up production and test environments. You can, in the portal itself, you can actually set up SSL, custom domains, things like that, which are really nice. And I really like it because it's really quick to get to production. It's really easy and it just kind of works. And so I'm a big fan of it. And there's also a free tier, which means you can get started for free and scale up if and when your demand meets it there. So let's jump into the last demo. And the first thing I want to do is go ahead and pull up the actual web app. So the first thing I want to do is pull up my application. And if I go to the app service tab over here, I can actually find my web app, right click it, browse to the portal, browse to my web app. Let me pull that up. And so this is the web app I built. And if I go to repo here, I can insert whatever repos I want that are publicly available. And as I do that, what it's going to do is call the Cosmos database. And you can see here it has on the right a lot of the most recent issues that we're seeing with links directly to GitHub. Or if I double click into there, it'll show me the whole JSON blob for that issue. Some summary stats on the top left. And on the bottom right, all the key phrases that we extracted through cognitive services. And so I can say, OK, well, all the issues that are related to type, for example, right? And it'll pull up a page with all the different issues with type going on in the extension. And we can see what other things that they were tagged for, links directly to GitHub, and the IDs for those issues. So we can double click in and just see all the JSON blob. It's super convenient. It's really kind of, I think, is a pretty cool web app. But let's talk about the productivity gains you have by using the extension. So the first thing that's really cool is you can actually create a brand new web app. And so if I follow this flow, in just a few commands, I can set the name for the web app, I set the region, and it'll deploy the current code that you see here into Azure. There's nothing special about this Flask application that makes it work with Azure. It's just a simple Azure application. If I want to redeploy, I can just click this blue arrow, select the folder, and then it'll tell me, hey, we're going to overwrite your application with your new code. I'm not going to do that because I'd like to show you a few more things before we jump into there. The other thing that's really interesting is you can actually stream your logs. So if I right click here and you start streaming logs, we're going to stream our logs directly in our coding environment so we can see what's going on. And if I open up our web app again, what's going to happen is you're going to start seeing a bunch of different logs as I click around on the web app off screen. If we do run into issues with our application and you're trying to find the logs and there's not enough information being spit out here, we can actually click into our application here, go to logs, and there's tons of different logs from deployment logs to all the different traces, and you can actually view them again directly in your coding environment, see what's going on, which is super cool. So we'll click here, we'll go to trace. Once this opens up, here's all the different trace logs so we can see everything that's kind of been going on, which again I think is super cool. The other thing about this is we have a .env file that contains all of my secrets for my Cosmos database account. As you can see, I'm using them here to establish a connection string and this simple method. And so when I deploy this to Azure, when I push this into a public repo, the .env file does not get included as part of the .gitignore. And so what happens is post-deployment, I'll get a notification on the screen to upload that as app settings for my application. Or I can go into here, right-click and upload local settings to be able to upload my settings. It'll do the diff and add just the new ones. I can add new settings here. And if I'm ever starting fresh, I can actually download them first. So download the remote settings, add a couple things, then re-upload them. So that's super, super convenient. Some other really cool tips and tricks is the SSH directly into the web app. So this is super cool, especially if you're doing like a Django app and you need to run a migrate after you've deployed. You can right-click, initialize the SSH, and you'll see in about 5 seconds, there you go. The SSH is wide open. I can jump in, type in migrate, do whatever I need to do, and then pop out of the server. And then finally, the last thing I want to show you is you can actually configure the deployment source directly from your coding environment. So if you're at the stage now where you deploy this you push this to GitHub and you want to configure the deployment source to continue to deploy from GitHub moving forward, you can go and do that simply by right-clicking there. Some of those key takeaways, there's a ton of different things you can do with the app service extension. The create, deploy, streaming logs, all those other integrations, they all, again, save you time. And time is so important, especially in these days. With app service, it's really easy to get started. And it takes a lot of the other work off your plate so you can focus on writing your Flask or Django app or whatever web app you're trying to build and let us kind of handle a lot of the infrastructure and management of everything else. Finally, if you're a CLI person, you prefer the CLI, and you can download the AZ CLI, and then from any command terminal, cd into your folder, run the AZ web app up -n and your app name, and it'll actually zip deploy your app directly in Azure for you and configure it. So that's just a super cool tip. And finally, hopefully the takeaways that you've gotten from this demo is One, Azure is incredibly powerful with Python. It's definitely a first-class language. We continue to improve it. Supports Linux and multiple OSs. With VS Code, it speeds up your development time. It helps you get to something real much faster, which is always super cool. It's always exciting to finally see the finished product at the end. And it's only going to get better. We continue to invest in the extensions. For example, the Azure Static Web Page App extension just got released, I think, yesterday, which is super cool. And then finally, the Azure Python SDK is super, super awesome. If you're not using it, you should definitely check it out. And that ak.ms link below has all these links to the repo, the slides, and everything else if you want to continue this journey. So thank you so much for joining. This was an absolute blast. I hope it was valuable to you, and thanks so much. Now I'm going to pass it over to Nina so we can kick off the Q&A.
Nicholas, thank you so much for your action-packed talk. I learned a lot. I really appreciate your presentation, and it looks like we have some great questions waiting for us. So Corey asks, he noted that in your VS Code environment that you're using the Python venv. Is there anything a dev needs to know in order to use that?
Did you say the VM?
The virtual environment, yes.
Oh, yes. Yeah, of course. No, the virtual environments can be set up pretty much anywhere. VS Code helps set you up themselves. There's also a few command lines to actually set it up for yourself. I like it because it isolates your environment. I actually gave a talk last year and broke my demo the night before because I didn't set up an environment and updated one of my packages, and it fell out of the dependencies. So there's not a lot of work. You can actually go to the app service Flask to quick start, and that actually walks you through how to set it up the first time.
Yeah, and if you noticed in the VS Code window, there was the virtual environment that was currently selected was just clearly on the bar on the bottom right there, that blue bar. So you can click on that actually and select any virtual environment that you'd like. So Jovo asks, while you're creating your function app, you're probably selecting the option to publish Python code. Are you limited to libraries that Azure, are you only limited to the Python libraries that Azure offers? Or is there a way to specify what dependencies your application has?
Interesting. So can you repeat that one more time?
So when you're creating a function app, Jova asks, you're selecting the option to publish your Python code directly. And he'd like to know, are you limited to using libraries, the Python libraries that Azure offers, or can you provide custom libraries or dependencies?
Got it. So you can do your own custom dependencies. I'm not entirely sure what the workflow is for that, but I know that is available.
Great. Thanks so much, Nicholas. Yeah, I personally really appreciate that you're sharing all of your code on GitHub. It's available at that link, aka.ms/build2020pyvc. You gave a really high-level overview of a lot of powerful tools. And if folks want to dive in, they're able to get all of the resources that you use to create your demo.
Yeah, and I'd like to add to that as well as we actually set up a Discord channel. It's kind of like an online chat room filled with a bunch of different engineers and PMs across Microsoft who are interested in Python. And so if you have any questions as you're going through this or any random questions about VS Code or Python and Microsoft in general, definitely just stop in and talk to us. It's filled with a ton of different Microsoft folks right now. So we're super interested to talk and kind of help wherever we can.
Fantastic. One update about our functions question. For custom packages, you can add them to a requirements.txt file. So you are not limited to, you're not limited in any way with what kinds of packages you can include in your function. Nirav asks if you can provide the GitHub link for source code being used. Does it make sense? Do you want to pop open that AKA link, Nicholas, and just give the folks watching a quick tour of the resources that you have shared?
Of course. Let me go ahead and pull that up.
So at that link, you should have the GitHub repository. There's a link to the Discord, where folks can join and ask questions. Discord is a chat platform. There are tons of questions that we don't have time to answer in depth, unfortunately, but we really encourage everyone to check out this link, join our Discord, and engage with us. And with that, we are wrapping up. I just wanted to thank Nicholas so much for giving us this amazing talk remotely, and for the production crew and the moderators and everybody else who has helped make this session a success. So thank you all so much for watching and for joining.
Thank you.
And thank you, Nicholas.